Okay, I'll be getting started now. Does anyone have any questions or comments on what we did before? If not, let's get into it. Okay, so this lesson's going to be about, well, it's going to expand on what we did on Friday about quadratics. So binomials are where there are two terms. So this is a binomial. Likewise, something like this, it's addition of two terms. Binomial bi, which is a prefix meaning to nomial, which is the other part. So when we square binomials, like let's take this. Well, let's try it. X plus 3 times x plus 3. X times x squared plus 3x plus 3x, 9. Okay, so x plus 3 squared equals x squared plus 6x plus 9. How about the binomial I mentioned before, 2x plus 3? So if we do the same thing before and add it, this ends up as 4x squared. This times this plus this times this. How about something like x plus 5? So when you have all these binomials, do you see a pattern here? If I had something like ax plus b squared, what would that equal in terms of a? What expanded would that equal in a, x, and b? So you could pattern search, but I'll just skip that and just do the hard math behind it. So ax plus b times ax plus b, this sums up to ax squared plus 2ax bx plus b squared. This matches up what we have here. A is 1, this is 1, this is 2 times 1 times 5, 25 is 5 squared, etc., etc. So why is this important? So last time we learned about quadratics, which are functions like this. And we wanted to find solutions. But a really easy way to solve these quadratic if they were something like this. Equals, no, minus, equals 0. So x plus 7 squared minus 4 equals 0. This is a quadratic, since this sum expands into this, which matches up with this format. And this is really easy to solve, since x plus 7 squared equals 4 square root x plus 7 equals minus negative 2. X will equal either negative 5 or negative 9. So putting a quadratic in terms of a square of a binomial plus or minus something makes it really easy to solve. As a side note here, if we had this equation, which it's plus 4 instead of minus, then we would end up with something like this. And you can't square root negative numbers, or on the other hand, anything squared is positive or 0. So this becomes impossible to solve, where there are no solutions to this. So how do we form a square of a binomial plus or minus something out of a quadratic? Okay, so if we have ax squared plus bx plus c, so we want to turn this into something that dx plus e squared minus f. I will just use the alphabetical variables for now. So x is a sort of x here. Each term has to cancel out between each side. So for the x squared side, each side has to be the same. So the x squared term here on this right side has to have a coefficient of a, while the x term there has to have a coefficient of b. So if we expand it out, okay, so the x squared terms have to match coefficients. So a equals d squared, or on the other hand, d equals square root a. The x terms have to match coefficients. So b equals 2de, which if we substitute this in, equals 2 square root a e. So e equals b over 2 square root a, which if you put it, if you rationalize the denominator, which is something we'll cover later, you'll have this. And then e squared minus f is c, since the constant terms have to match. So e is this squared, so it's b squared over 4a. F equals b squared over 4a minus c. But the important part here isn't to really put the things down to formula, but more so have an instinct for it. But if you wanted to turn the quadratic like this into this form, you would have d equals square root a, e equals b over 2 square root a, and f equals b squared over 4a minus c. On the other hand, you can observe that e equals b over 2d instead, which makes this, it leaves square roots out of there. As a more comprehensive way, you can just square root this and divide this by 2 over the square root of that. Now that we've done that, can anyone complete the square of 4x squared plus 24x minus 20? And also, does anyone have any questions? Another way to form a square is to first expand out the binomial, say 4x squared plus 20. Is to first have the x squared and x term, and then to add something on to make it a binomial. So like this would be $36 makes it a binomial of 2x plus 6 squared. Okay, so 4x squared plus 24x minus 20. On one hand, you could write the how what the generalizations or formulas of what we did before. On the other hand, you could find a binomial that matches these two because the constant term doesn't change with the binomial. So 4x squared plus 24x plus 36. So this is our binomial of 2x plus 6 squared. So, but this is this plus 56. So what we have to do here is minus 56. So this equals this. If you want to carry out this way, f equals then d equals 2, b e equals 24 over 2 times 2 is 6, b squared 36 over 4 times 4. No, that's I don't think this is well, I made a mistake here, but it's minus 56. Okay, so now that we have this, you can plug in 0 equals 0 and put in 56 on this end. Square root 56 equals 2x plus 6. This, you can take out this, divide by 2, x equals 3 plus or minus square root 14. Okay, now we're going on to the quadratic formula. So we had this equation before, but there is a quicker way to solve the equation than just by completing the square. So I'll derive this formula, actually the quadratic formula. So ax squared plus bx plus 3 equals 0. We want to find two roots. So first I can use the form. I can complete the square on this with plain variables. So d equals square root a, e equals b over 2 square root a, and f is, so keep the constant term constant. F is b squared over 4a plus c. Okay. So, and this all equals 0. So if we do the same thing as we had with, as if these were constants, then we move this off to the right and square root. So square root ax plus b over 2 square root a equals plus minus square root b squared over 4a plus c. Okay. And then if we multiply square root a to this whole thing and 2 square root a as no, only square root a actually. So multiplying a square root a to each side, x plus b over 2, the half remains on both sides, so I don't have to multiply it out just yet. This is ax, b over 2. So radicals, one multiplied, combine the thing in the symbol. I don't actually recall what the symbol is called, but b squared over 4 plus ac. If we move a half down to the bottom, this puts in a 2 here, and then the 2 gets multiplied twice into the radical because it's a half root radical. So multiplied by 4, and then this b gets shifted inside, and the a gets divided. So we leave off with negative b plus minus, I forgot it here, b squared I'm not sure what went wrong, but this should be a minus 4ac over 2a, which is the quadratic equation, quadratic formula. Negative b plus minus square root b squared minus 4ac over 2a. No, I calculated f wrong. F should have been e squared minus c, which is how I flip this sign here. It should be minus c. This formula is convenient because it's done for you already. You can just plug in everything. If you have A, B, and C, you can just plug them in and directly get your answers. You don't have to factor, you don't have to complete the square. Sometimes it's a bit quicker to factor if the numbers are, if the solutions are integers, but a lot of the time, this is just the more direct method. Okay, some things about the formula. So plus and minus. So quadratics, as we've had before, have two solutions, which is part of a deeper principle. Actually, if you had a polynomial, which is a combination of x squared to an integer power, so like axn, bxn minus 1, etc., then the highest power of x has, like for this polynomial, this should have n solutions if there aren't any double solutions, and including imaginary solutions. But yeah, there are two solutions here. They have a differential of square root b squared minus 4ac over a, which is because of the plus minus. B squared minus 4ac is in the square root. But if b squared were to be more than 4ac, so b squared is always positive. However, if 4ac was more than b squared, then this would be negative. However, you can't square root negatives. There's no number that makes this, that equals square root negative 29. So what happens is that there's no solution because you have this square root of a negative. Later on, when we talk about complex numbers, they will have solutions, but they're not real, which is about the number types we talked about in our first lesson. Does anyone have any questions? If not, I'll be ending the lesson here. It's a short one, but the next one will be longer.